Improving text-to-SQL performance with ease on Databricks. This is a blog post that we saw from a team at Databricks, which they use basically the Spider benchmark. The Spider benchmark, basically, it's a recognized standard for evaluating how well LLMs are performing when they take some text and, try and, transform that into a SQL query. So here, they just deep dive into how they managed to achieve really high scores by using an open source Llama 3.8b Instruct model that they fine-tuned, and a really remarkable 19-point improvement over the baseline. They started with something good to keep in mind. Always have to start with a baseline performance before you start jumping into optimizing your prompt and fine-tuning your prompt. They started with a very simple prompt where, you have a create table statement, text, sort of question that needs to be translated into a SQL query. That gave them the baseline benchmark, and they're going to improve everything from there. Started by just adding some sample rows, because basically here, all you have is you don't have any context about the data except for the data types for the columns. So what they did, they just added some row, examples to add some context that allowed them to increase the score by 6 percentage points.
Very nice.
Then they moved on to few-shot prompting. It's a strategy where in the prompt you can just add some examples of what good looks like, so that the LLM can see those examples and get inspiration before it provides an answer. So basically here they would provide a question, like a create table statement, a question, and then the example SQL query that is expected, so that the LLM can start learning from that. Also, what they did improve on the previous zero-shot prompt is to include what we call a system prompt, your helpful assistant, blah, blah, blah. So I think we've all seen
more context.
Yes,
to
exactly.
Yeah.
We've all seen those examples. So you have this, you have the example rows, and then you have the examples that are given, with what the SQL queries should look like based on the question, etc. Here, they mentioned they probably reached the limits that you can have in terms of fine-tuning the prompt, etc. And so they did, the next step was to fine-tune the model. So fine-tuning.
Nice. Up to here, they didn't touch the model. They were just doing prompt engineering mainly.
Exactly.
So tuning the prompt till they found the best they could get. Okay.
Exactly.
And now they go to the model.
Exactly. And for that, they use some training data that's a data set that's included in the Spider benchmark, actually. They just managed to do that in just a few hours. So I'm not going to go into details here, but basically first they needed to take this training data set, just format it so that, the LLM could learn from it. And they achieved another 9 percentage point improvement on their previous basically fine-tuned prompts. Now they've already done quite well, but also what I found super interesting here is that then they looked at how good this fine-tuned Llama 3.8b was doing compared to a much larger model, Llama 370b Instruct. And so they repeated the benchmark, and actually only marginal, but what's really interesting is that this fine-tuned smaller model was scoring higher than the Llama 370b Instruct. This is something that's interesting because it really shows people that you can choose a smaller model that's, less expensive, to train, etc., and still achieve comparable, if not better, output than a larger model. So it's a very good example.
So here to understand, they tuned with Laura's the Llama 3.8 billion, but the Llama 370 billion, they just did some prompt engineering.
Yes.
Okay, so we were comparing the fine-tuned model versus the base model.
Yes, exactly.
Okay, the base bigger model.
Bigger model, even though the base bigger model is larger and should perform all things equal better than the smaller one, because you fine-tune the smaller one for the specific task that you want to do, which is here text-to-SQL, just for this specific task, is going to be better. It's interesting because we always talk about all those, leaderboard of which LLM is the best, etc. But in the end, it's all about what do I need to achieve? And if I fine tune it for the task that I want to achieve, maybe I can just have a smaller one and just work on fine tuning it. So I thought that was really interesting because they showed the end-to-end example. Then, like obviously you want to like log it in UC, create an endpoint and, deploy it to the endpoint. And yeah, really great.
And now here on the model serving a much smaller tuned model. It's so less heavy and so cheaper than serving the huge, like 70 billion Llama 3 model, right? So
Exactly.
more quality and better performance in terms of inference with the fine-tuning exercise.
Exactly.
Okay.
And Appendix I also really like that they put everything so that you can try and recreate it yourself. So they put all the examples.
Do they have shared the data they fine-tuned on? That would be interesting to see.
To fine-tune, it's a training data set that's with Spider.
Okay.
And so, you can have everything here.
Amazing. Looks great.
Yeah.